Let's take a few moments to just stop and talk about scale and what that means. In this unit, you're going to observe substances on two different scales that you've heard before. Uh, well, one of which you've heard before. The macro scale is substances that can be observed with the human eye, like that glass of water that you see on the left-hand side. That's something you look at every day. The micro scale or the molecular scale is what you'll hear it called to a lot, is molecules that are too small to see with the human eye. Molecules are just particles that make everything up. So we're going to use, because we cannot see the molecular scale, we're going to use a sim to look at that. And I'll show you how that works. To bring this back to our whole question about what happened to that lake on Titan, we know that we can see the picture of the methane lake at a macro scale with our eyes in a picture, but we can't see what's happening with the molecules that we know make up that liquid methane. So that's what we're interested in figuring out using a model like a sim to try and see what those molecules might be doing at the micro scale. So this is just to familiarize with the different parts of the sim that you'll get into in just a minute. These purple dots are going to represent your actual molecules or particles. You can change the substance from A to B to C to D. I'll show you how to work with substance A, and then you'll finish out using substance B and C on your own. You can play around with the amount of energy. You can transfer energy into and out of those molecules. Don't really worry too much about that right now. If you do play around with it, you'll also notice that the temperature on the left-hand side will go up if you transfer energy into those molecules. You can also rotate, bump, and move these molecules around, but we're not really playing with that right now, so don't worry about that last part. So I'm going to show you how to work with substance A first. And I'm in the sim. If I go to substance A, I'm going to press play for a little bit and pause it. Given what I know about different phases of substances on a macro scale, solids, liquids, and gases, I know that solids do not take the shape of their container. They're usually just not going to flow with the container. So my first guess is that A is a solid because it's not taking the shape of its container. You'll see that substance B is a liquid and substance C will be a gas. And those molecules in substance B and C will look a little different than they do in substance A. So I press play to see what the molecules will do. You notice that they're kind of vibrating in place. So on the molecular scale, those molecules are not moving very much. They're just kind of vibrating. Another thing I want to show you is you can click on one molecule and track the motion of that molecule. Now in a solid, it's not going to move. That one little tiny molecule I highlighted in red, it's not going to move very much. But you might see something different happen in a liquid or a gas, and it tracks the motion of just that one molecule. You'll see the little red lines there. That's what that's doing. What you're going to be asked in the next section after you play around with this sim is to write down observations of both the macro scale and the micro scale for substance A, B, and C. So a macro scale observation for substance A would be the solid, it's a solid, it does not take the shape of its container. A micro scale or a molecular scale observation of substance A would be that the molecules move closely together in place. Like the molecules don't really move much, they kind of vibrate in place. That would be my observation at the micro scale. You're going to do that for both B and C. You might want to stop and jot down what you just heard me reference for A. All right, if you need any help, always reach out.